Okay, decision trees, obviously we use these to make decisions. When in the event of uncertainty, and the advantage of decision trees is we can integrate deterministic probabilities. So this is another way of saying that we want to incorporate uncertainty. We have a pretty good idea of what that uncertainty would be, as opposed to just being random. So we're going to make a decision. We denote that by the box, and the first step we need to do is identify all the alternatives. So in this example, we may have 3 alternatives, or choices is probably a better way of putting it. We have alternative 1, we have alternative 2, we have alternative 3. And for each alternative or option, we need to identify the states of nature. So a simple example could be whether it's going to rain or not. So rain or shine, rain or shine, rain or shine. Or this could be high demand and low demand, high demand, low demand, high demand, low demand. So it really doesn't matter, but generally the states of nature are the same per each alternative. It's the alternatives that are different. So for example, if we are going to buy a computer-assisted device to manufacture, we could have high demand once we produce the product, or we could have low demand. Conversely, maybe we're going to hire engineers and do it in-house. We're still going to have high demand and still low demand. So states of nature, the second piece, is going to be consistent throughout. And then we're going to have outcomes here at the end based on the alternative and the respective states of nature. So let's just say for coding, this is alternative 1A and 1B. This is alternative 2A and 2B. This is alternative 3A and 3B. So with the states of nature, we're going to have probabilities for each. We probably want to keep these probabilities consistent throughout. So this probability of low demand here is the same as this here, as the same as this here. But within each alternative that we examine, regardless of how many probabilities we have, those respective probabilities need to add to 1. So in this example, wherever we have it, the probability of a high demand plus the probability of a low demand equals 1. So this might be 0.4 and this might be 0.6, and that makes sense within this alternative. Same here, 0.4, 0.6, 0.4, 0.6. So what we're going to go for is an expected value or an expected monetary value based on the outcomes. So, and that's what this is going to look like. So for alternative 1, we're going to end up with an expected, we'll just say it's a monetary value. It doesn't have to be a monetary value if we're using a decision tree and we just want to assign values. It may not have anything to do with money. but it's essentially the same, which is a weighted average. So we are going to take the probability of the high times its respective outcome. So that would be outcome 1A, and we would add that to the probability of the low here times its respective outcome. And that's the expected monetary value of alternative 1. And then we would do this all the way down. So we would have the expected monetary value of alternative 2, which would be the probability of the high against outcome, or multiplied against outcome 2B, plus the probability of the low times outcome 2B. This should be 2A. So probability times outcome, we take the sum of those two products. And then finally, with alternative 3, the expected monetary value is the probability of the high times the value of outcome 3A, plus the probability of the low times outcome 3B. And then we would compare these values, these 3 expected monetary values, to see which one is the highest. And then we would, based on which is the highest, we would use that to support our decision for that respective alternative or option. So in this example, if the expected monetary value for alternative 1 was highest, then we would use that to support our decision. Finally, this is sometimes a little bit difficult for people to imagine, especially when these aren't monetary values, because these values themselves aren't real values. They are real, but they're hard for people to get their arms around. They're averages based on the respective probabilities. So if this was $500,000, it doesn't necessarily mean that we have an opportunity to make $500,000. It means that based on the probabilities and risk, it's a means of comparison at $500,000 against this means of comparison. But it doesn't really mean that we're going to see $500,000. If we get a high demand, then maybe we'll see even more than that. If we get a low demand, we may see very much less. But it doesn't mean that if we choose this alternative, we're necessarily going to see $500,000 as a profit. That's not the point of this. The point of this is to essentially have a reference to compare alternatives against when making this decision.